this is an old exam paper question, so you guys need to make sure you know how to do it, okay? It says a block of mass 8 kgs, here it is, okay, is resting on a rough horizontal table, which means as soon as we see rough, we think force of friction, okay? Is connected by a light inextensible string. What does it mean? It doesn't stretch. Inextensible means that it doesn't stretch, which passes with a light frictionless pulley, which means doesn't participate in this equation in either sum whatsoever. We don't care about it. To pull another block of mass 5 kgs. Okay, the block hangs vertically as shown in the diagram. Okay, now it says there's a 15 Newton force is applied to the 8 kilogram block at an angle of 30 degrees, causing the block to side to the left. So I'm going to say that that's the positive direction. Okay, now it says the coefficient of the kinetic friction between the 8 kilogram block and the surface of the table is 0.25. Okay, ignore the effects of air friction. It's always nice. Okay, now the first thing they ask us to do is draw a free body diagram showing all the forces acting on the 8 kilogram block. Okay, so let's do that. It says draw a free body diagram showing all the forces acting on the 8 kilogram block. Okay, so it's a free body diagram, so we want a colored in dot. Right. Do you agree? Sorry, I just really don't like when it does that. Okay, so it's a colored in dot. Right. Do you agree that we have a force of gravity and it is down? Force of gravity. And then we've got the force up, which we can call the normal, or you can call it the force of the table on the block. Okay, right? There is this force here, which is basically the force of the, well, we can call it the tension. The tension in the string, which is actually caused by the weight of the 5 kilogram block. This is the tension. There is a force of friction over here, and they said there's a force of friction between the 8 block, but do you see that it's moving to the left? They said to us that this whole thing is moving to the left. So therefore there's a force of friction this way. And finally they say there is this 15 newtons, and I know that's not quite at an angle of 30 degrees, so let me make it neater. Okay, let's just do that neater. There we go. Oh, still not 15 degrees. Okay, never mind. 15 newtons. Okay, and that's supposed to be an angle of 30 degrees. It's more like 45, but never mind. Okay, so those are all the forces that are acting on this. Okay, ta-dang, done. Now it says, calculate the magnitude of the normal force acting on the 8 kilogram block. Okay, now normally we would go, well, the force of gravity matches this force, and therefore that must be the same as this. However, what do we have here? We have got this 15 newtons that is doing two things. It is pulling the block to the left, but it's also pulling the block up. And since this block is stationary in the vertical direction, okay, the block is not moving down and it's not moving up, it is stationary. This means the vertical component of this 15 newtons plus this force here have to equal the force of gravity down. So therefore this F normal does not equal Fg in this case, because the fact that we have this component here, which is pulling it up as well. So together they have to equal Fg, which is why I didn't label this F normal. I labeled, but is F normal, but it's basic. I didn't want you to think of it as the normal force, which is always equal to force of gravity. In this case, this is F normal, but it doesn't equal the force of gravity because of this vertical component that is also pulling it up. So we need to work out now what this is. So in order to do that, the first thing we need to do is work out this vertical component. So we're going to use SARCA TOA. We want the vertical component. Okay, we've got the hypotenuse. The vertical component is opposite to the angle, so we're going to use sine. So we're going to say sine of 30 degrees is equal to the opposite, which is, I'm going to say, force vertical over the hypotenuse of 15. So we're going to go 15 sine of 30 degrees equals force vertical. And we're going to go 15 sine 30. And again, grade 11s, I'm going to stress with you guys that you make sure that this does not have a big R there, because that probably means that it's in radians. If it's in radians, you're getting this whole sum wrong, because this needs to be in degrees. Okay, so that's 15 over 2, which is just 7.5. So that's 7,5 newtons upwards is the force vertical, right? So that's 7,5, right? The weight of this object, force due to gravity, this here, okay, Fg equals mass times acceleration, mg. The mass of the object's 8 times by 9, 8. 8 times 9.8, which becomes 78.4. 78.4 newtons. Therefore, we can say that the normal force is going to be 78,4 minus 7,5 minus 7.5 is 70,9. So the normal force in this case is 70,9 newtons. So that's a nice question, because it's the first time we've really seen how the normal force is not necessarily equal to the force of gravity if you're pulling it up with a tension in a string or something. Okay, right, so we've done that one. Now it says calculate the magnitude of the tension in the string connecting the two blocks. So they want this, they want the tension in this, okay? So this dude here, let's draw his free body diagram and do it over here. There are only two forces acting on it, which is quite nice. There's the force down, which is the force of gravity on the 5 kilograms. And there's the force up, which is the tension. Okay, so that's nice and easy. So do you agree that this one's equation is really easy? We've got F net, or F res, is equal to MA, which equals T plus the force of gravity. But we've chosen this as positive, which means that this force of gravity is going to be negative. So therefore, it's the mass, which is 5A, is equal to T minus 5 times 9,8. So therefore, we can say that 5A is equal to T minus 5 times 9.8, which is 49. 49. And that is equation 1. Now we need to look at the 8 kilogram one. And before we can do that, we actually need to work out this horizontal component here, because this horizontal component of this 15 Newton force is the component that's actually pulling this to the left, okay, not the 15 Newtons. The 15 Newtons is doing two things. It is pulling it to the left and it is lifting it up, but only this horizontal component is pulling it to the left. So let's do that. If we do it over here, I'm just going to write it over, draw it over here. So we're looking at this line here, and this is the adjacent, and we know that the 15 Newtons is the hypotenuse. So if we look at SACA TOA, cos of 30 degrees is equal to the adjacent, which is what we want. So I'm going to call that F horizontal over the hypotenuse of 15. So we've got 15 cos 30 degrees equals F horizontal. 15 cos of 30, close bracket, equals 12,99. So the horizontal component is 12,99 newtons. So this thing is being pulled to the left by 12,99 newtons. Okay, so now let's look at the horizontal movement. We know that the net force on the 8 kilograms is equal to 8A, which is equal to, now let's think, we're choosing this as positive, right? To the left is positive. So it's equal to the force horizontal plus minus T plus minus the force of friction, right? So that's 8a is equal to the horizontal component, which just worked out was 12,99, minus the tension, which is what we're trying to find out, minus the force of friction. But the force of friction is equal to minus the coefficient of friction, which is 0.25 times the F normal. And the F normal is what we worked out just recently. We just worked it out now. Times the F normal. And that's why they asked us to work out the F normal. Okay, so what did we work it out to be? 70,9. So that's what they asked us to work this out. And remember what I said to you before grade 11 said, they always give these things in order for the information that you want, okay? So in other words, they're not going to say to you, oh, prove that the color of the sky is blue, and then the next question is how deep is the ocean. Everything is related. So the reason they asked you to work out the normal force was because we need it for this question here. Okay, so therefore we can say that 8a is equal to 12,99 minus t minus bracket 0.25 times by 70,9. And now we can pop that in our calculators and get the numbers together. 12,99 minus bracket, this thing here, 0.25 times by 70.9, close bracket equals, which is minus 4.7. Remember, always two decimal places, so it's minus 4.74. So we've got 8a is equal to minus 4.74 minus t, and that's equation 2. Now remember, we're working out the tension in the string, and we've got two equations. We've got this dude here, and we've got this dude here. Okay, so we're going to solve both of these for t. So t is going to equal 5a minus plus 49. I've just taken the 49 across. So now we're going to make that equation 3. And then this becomes, take it across, becomes t is equal to minus 8a minus 4.74. Okay, and that's going to be equation 4. And now we're going to equate equation 3 and 4. So we're going to go 5a plus 49 is equal to minus 8a minus 4,74. So we take all the a's to one side and all the other things to the other side. So we got 5a plus 8a is equal to 49 plus, minus 49 minus 4,74. So therefore you've got 13a is equal to minus 53,74. Now we need a calculator. So we can say that that is 53.74 divided by 13 equals 4.13. So it's minus 4.13. So that's interesting. So it is moving to the left, but it's slowing down. Okay, so it's moving to the left, but it's slowing down. Okay, so its acceleration is minus 4.13 meters per second squared, but that's not what they asked. They asked for the tension. So what are we going to do? We have to substitute in, and I'm just going to substitute into equation 3. It makes it easier. So I'm going to go 5 times minus 4,13 plus 49 equals 8,35 what? Newtons. Okay then, sure, quite a long question, quite tedious, okay, but if you just take it baby steps, you can always do it. But remember that even if they ask you to only draw the free body diagram of one of the objects, draw the other one, because it really helps you. It really helps you to understand what's going on.